All right. Thank you so much, everyone. Thank you for the opportunity. Thank you, Ministers of Data and the whole team for the privilege to be presenting here. My name is Peter Oseghale. And before I start, I also want to say a very big thank you to Deborah Melvin. She was our mentor and she helped us really, really well. She was great, very receptive, and also very patient. Thank you so much, Deborah, for everything. Okay, so my name is Peter Oseghale and I have my co-presenter here. His name is Sunday Anah. And when he comes up, he will give more introduction himself. So I'm just going to share my screen now. So you let me know when you can see my screen, please.
We can see your screen.
So I'm just going to start presenting. Sorry. Okay, you can see my slide, correct?
Yes, we can see your slides.
All right, so our topic for today is best practices in Power BI data modeling. And your, should I call us hosts? Our face and Sunday. Okay, so this will be our focus and agenda for today. We'll be looking at data modeling as a foundation in Power BI. Then simple and clean tables. We'll also be taking a look at relationships and cardinality, measures and calculated column using DAX functions, data and table modeling, and also performance optimization in data modeling. After which we'll go into the demo that will be done by Sunday, and then if we have the time, we can also have a Q&A session. All right, so this is a brief introduction about me and my co-presenter. My name is Peter Oseghale. I am currently a Microsoft Student Ambassador. I am a data analyst and I love to write technical blogs to share my learning or something I discovered newly. So these are my LinkedIn profiles, my social media profiles. That's my LinkedIn, and my Twitter is also there. My co-presenter's name is Sunday, and he's also a data analyst. He is gradually transitioning into data engineering, and he loves data modeling as well. You can also follow him on social platforms, LinkedIn and Twitter. If it's okay by the post, we can post the links on the group so that you can as well click and just take you there. So today we'll be looking at data modeling, like I said, and we think this is the Power BI foundation because when you are working on a data analysis project and you have to fetch data from different sources, for those of us that use Power BI a lot, you understand that with Power BI you can you can get data from different places. You can get data from text CSV, you can get it from MySQL, you can get it from even the web, you can get it from JSON files. There are so many connectors that you can get your data from Power BI. So when you are bringing all of this data from different sources, it is important to bring them together, right? That is basically what is. Now this is this is a diagram that shows the circle moving from different resources, bringing them to a particular place called the data warehouse, where all of these data from different sources are stored, and then model the data. Then you can now subsection them into sales, customer, products, depending on whatever dimension it is that you need for your report. Then after this subsection, then you can now report and how they are connected, how they are related to one another. That's basically what data modeling is. And this is the image that shows a basic data modeling. So our images are we collected them from the internet, and if we can't share the slides, you see the link to get them linked on each of them. So every image has their own link and resource linked on them. So now we're talking about best practices in data modeling. Why do we even need to model our data? I remember I asked that question when I started out in data modeling, because there are so many data that you necessarily do not even need to model because they are already relatively small. So you don't need to break them down into dimensions anymore, and you can just do a report if you are doing something very, very simple, right? So why do we need to model data? Why do we even need to adhere to best practices in data modeling? Now, data modeling helps in enhancing performance, right? So let's say you have a master data that is extremely large, and you want to be able to tell the story using this data. You want to be able to visualize the data. It is easier for you to break them down. When we move forward, we'll be talking about stats, schema, pattern tables, and also measures and how they enhance performance in your getting your report and analytics, right? So, and doing modeling in Power BI helps to enhance your performance, the performance of your analysis, right? And then it gives you accurate insights. So there was a time I was working on particular data sets and I had connected all of the tables the way that I needed it. But I didn't know that I did a wrong connection between two different tables. So I took a different column and connected it to another wrong column in another table. So when I did my analysis, I noticed that I got a different value, in fact, a wrong value. How did I know that this value was wrong? Because I had already done a manual reporting. So before I do my reports, I always draft out or sketch out my reports in a sheet of paper and then write out and do the manual calculations of what I want to get from my reports, right? Write them down on my sketched report, and so that when I'm comparing, I see that it matches. So when I did the comparison, I noticed that what I had on my paper was different from what I had on my laptop. So I quickly went to my data modeling and checked. So from there, I noticed that my insights were wrong or my calculations were wrong, not exactly because I did not get my measure correctly, but because I did not link the right column to another column in the table. Then simplify navigation. So when we are talking about fact and dimension tables, the fact table is like when you have your transaction or your sales table, it has everything. It has customer, it has profit, it has product, it has the date. Everything is just so compact in one table. But when you break them down into fact and dimension table, then you can now know what is for what. For example, you can have your customer data. Now it has become a dimension table. You can have a table for products that is talking about everything that is related to product. You can also have a table that's talking about your table, maybe your date, maybe the order date, the ship date, the date that it was, you know, delivered to the customer and so on. Helps to see exactly, before you analyze the data, you need to have an objective in mind. So having these different tables explained and broken down into entities, it will help you to navigate easily around your data set. Now, before you model your data, it has to be clean and in simplest form, because you cannot model something that is not already clean. It might lead to more quality issues, and that can affect your analysis. So every table that you model has to be simple. Also, now, what are the terms of keeping tables clean, right? For those of us that do science so well, we know that when you load the data, it comes the average accuracy very mistake. And for you to be able to make sense out of data, you need it to be clean. For you to be able to do your analysis and get the right result, it has to be. So having a clean and simple table helps us to, helps us with clarity and understanding. It helps us to understand what it is that we need to do, right? Even after having the objective in mind. Having simple and clean table gives us clarity and understanding, more understanding of the data. Then it also enhances collaboration. So you want to work with a team member on this data set. When the data is clean and when it's simple, it is easier for you to gain insight from it, and you know that this is what I want to get. I want to use this data to answer this problem. Then it reduces complexity. This already explains itself. So when your data is clean and it's simple, things is no longer complex, right? So improve data quality. This helps to improve the quality of your data because now you can go on, do the measures you need to do the analysis you need to do, and then you come up with stories and insights to present. Then maintenance and update as well. When your data is being updated, right? Maybe you are fetching or you are getting an attendance data. When you're adding to them, it's easier for you to see. It's easier for you to see what you need to clean and what you need to do. So we're moving on to the characteristics of a simple table. So how is a simple table even supposed to look like? So you have to have clear and descriptive name. Your column name should tell what exactly is in that column. So if what you have there are names of people, what kind of names? Names can be from anywhere. It could be manager's name, it could be staff name, but you want people to know that this is a customer name. So you should have a customer name. Then the column should be well defined. The data types should be good as well, be accurate. Then the data consistency should be nice. You shouldn't have different, maybe having text and numbers in the same column. Then no data redundancy, the appropriate relationships, which we are even talking about. Then you don't need to have blanks or nulls in your data set depending on the objective. Then the indexing should be right as well. Then the data should load appropriately. Now we're going to be talking about normalized and non-normalized data in Power BI. So a normalized data is, or normalization is a data modeling technique that is used to organize and structure relational databases to reduce data redundancy and improve data integrity. So it involves breaking the database into multiple related tables, each with a specific purpose. So like I explained before, when you have a master's data, you need to break them down, right, into facts and dimensions. So the dimensions will now give you information into what is related to that particular entity. So if you're talking about customers, you can have all the information about customers. If you're talking about their demographics, you need to have everything about that. If you're talking about dates, you need to have other date, ship date, and the rest like that. So that's basically what normalization is. It's breaking down the database into multiple related tables, and each of them have their own specific purpose. This is an example of a normalized database. So like I said, when you scroll around this image, you can see the link to each of them. If it is okay, we can also share so that you can relate with them in your own free time. So this is an example of a non-normalized database. So a non-normalized database is the opposite of being normalized. Instead of being broken down into different tables, you can have them as one or as a table. So now we talked about the star schema before. This is a direct example of a star schema. You can see that the fact table is placed at the middle or in the center, and then the remaining, which are the dimension tables, they are scattered around each point of the star. Let me use hand now. So we have the product dimension table, we have the date dimension table, we have the reseller dimension table, we have the employee, and we have sales territory. This is also an example of a star schema. All these images that I'm showing is just to show you how a proper star schema looks like. Now, there is also the columns layout where the facts are connected to the dimension, but now the fact is not in the middle, it is down, and then the the dimensions are up. So you call the dimension table also the pickup table. So they are up, and it's like the fact is looking at them from down. So now we'll be talking about relationships and cardinality. I'm supposed to have arrows and words here. Okay, yes. So sorry. So now you can see this first one. This is relationship. This line that is showing that is not dotted. This is an active relationship, while the dotted line is an inactive relationship. And when you come here, can see that this is a cardinality. The cardinality is talking about how they are related. This one now is a one-to-many. The next slide is going to explain that to us. This is a one-to-many relationship, and it is pointing to this star here. This represents many, and the other one, this is a one. So the customer to sales is connecting in a one-to-many relationship. Then this box form of a square that has a small arrow inside. That is the direction of the relationship, right? So this diagram explains the relationship and cardinality in a data model. Now we have the one-to-many relationship, which I had already talked about, or cardinality, which is number one. So you see that the customer is filtering to the sales table in a one-to-many relationship, and you can see the arrow inside there. And also we have the one-to-one cardinality, which is from the customer, so the customer's socioeconomic data. You see, we have one-to-one. That's basically the explanation there. And then we have many-to-many cardinality. So the many from others is filtering to the fulfillment as many-to-many. So the many in others is going to many in fulfillment. So you can see that both of them. Oh my, I think I clicked something. Okay. So you can see that we have many here and we also have many in this other table. Right. So I've been talking a lot about measures. So measures is how you calculate in your, for example, you are using DAX. You are finished cleaning your data. Now it is time. You have modeled your data. Now it is time to report, right? So measure helps you to simplify the things that you've been using in your report. So you want to do sum, you want to do divide, just basically aggregations and calculations. Measures are very important here. And why calculated column is just having a column that is calculated. Now this means that the column did not originally come from the data set that you imported, but instead you did the calculations yourself, right? So with measures, there are no additional storage space. This means that it doesn't affect the performance of your data. For example, you are trying to load a Power BI file and it's taking so much time. That is not part of a reason why that should slow it down. Calculated columns can take space, storage space in your, in your data, but measures does not do that. So this is an example of the measure button. This is where when you want to create a measure in your Power BI, you just click on this new measure and then it brings that. And this is a total revenue year to date measure. This is a simple DAX measure. And when we get practical, we are going to see all of these things. Now, why do we even need to use measures in the first place, right? So I said that measures do not exactly take additional space in the model. So it reduces the consumption and help the consumption time of loading your data, and then helps the report to load faster. That's basically it. So it doesn't affect the time that it takes to load in your report. And also, we can also mention flexibility. You can use measures in as many visualizations as you want. For example, you want to talk about total revenue, you can use CAD visual to show that. But you also want to show the revenue by month. You can also use that measure that you use for your cards still in that different visual. So this is where flexibility comes in. And then reduce storage overload. I mentioned earlier that measures do not exactly take so much space, so it doesn't affect storage or overload anything. Then reusability. You can reuse the measure as many times and across different pages. So maybe you are working on marketing and sales. In your marketing table, or sorry, in your marketing report or page, you can use your measure. And when you also come to sales, you can also use the same measure. Now, let's also talk about consistency, right? So measures, they ensure consistency in your calculations and reporting. They provide a simple way to help you perform these calculations, and we will not have errors, because when you calculate something on Power BI using that, when there's an error, it immediately tells you. So this helps you to keep up very well with each of your measures and depending on what you want to calculate. Then we can also talk about clarity, and we are saying that clarity is very much closely linked to consistency, because when you name your DAX measures well, it will help you when you are creating your report so that you don't make mistakes. Because when you are calculating month to month, year to day, some of these things can be confusing. So when you are consistent with your naming and also clarify very well when you are using your measures, you can also type out, there's something called, I can't remember now, but you can, write on your code so that you understand what you're writing. When you are creating measures, this also helps. And then scalability. Measures can be, reused across multiple reports and dashboards, which is valuable in big organizations. So you have one data set, but you want to be able to tell different stories. You want to be able to tell different things. You can reuse this measure again and again, telling different stories and bringing in new insights. So I've been saying some things about code and the like. So the code you use in Power BI is called DAX, and it is data analysis expression. So there are functions that help you in modeling your data properly. So why do we even need to model data? That helps you in data transformation. It helps you in aggregation, time intelligence. Let's say, for example, there's some tables that don't come with a date table. So you need to create that, and you need to use DAX to create that date table. So it helps in the dynamic context. Yes, you use DAX to create measures. That also helps in your model optimization and data relationships. This is basically what DAX expressions helps us for. And this is the date and time modeling. This is a simple example of your date and time modeling. I believe that when we go practical very soon, we are going to see all of this. So, all right. So I've said a lot. I've said so many things. So it's time to show us how it really looks like when you are modeling your data and how to put all of these best practices into play. So I'm going to call on Sunday now, and he's going to help us with the demo session. So I'm just going to stop sharing my screen. Oops.
Yeah, good day, good day, good day. Faith has taken us through the entire session, and I hope to try to emulate her and try to put more substance to what she said. So I'm going to be presenting my screen. Do let me know once you can see my screen now.
We could see it for a second, but it's gone now. You should try again, please.
Okay. Can you see it?
Not yet. Usually takes one more click than you expect it to take in Teams. So you select the screen that you want to share or the window you want to share, and then you need one more click to confirm.
Why is it having so much issues? Okay.
Are you in a browser or using the Teams app?
I'm using the browser. So
The browser, if you click on share and then select the screen, click on screen and then select the screen that you want to share, then you should get a red box around the screen.
Sharing was cutting off.
Maybe Faith, do you have the slides or what Sunny wants to share? Maybe you can share and Sunny can guide you through the sharing.
Okay, I don't know if that's possible. Sunday, is that something you want to do? I think she already left the call. I guess he's having technical issues.
Yes, we've
Can you hear
also
me?
lost him. I hear
Can you
you
hear me?
again. I will
Okay.
make you presenter.
Okay, let me try.
I'll try again, please. Are
Okay.
you presenter now?
Yeah, I think it's coming up.
Yes, now we can see your screen. Perfect.
Okay.
Okay.
Okay. Apologies for the mix-up. I had to go back to the app. I had to go back to the app and try to connect from there. So I'll be taking the demo now, and I'll be connecting to my Power BI report that is currently opened. So for this, we're going to be using two data sets. We're going to be trying the sample data set available for everyone on Power BI. Before we start, I'm going to introduce myself. My name is Oseghale Chukwujekwu. I'm a data analyst and a data engineering and modeling enthusiast. I love everything, data engineering and data modeling, and I identify as a sport lover, football to be precise. I also identify as an angry Manchester United fan. It's not been going good for us, but we're trying. So, for every other United fan on this, if we have any, don't worry, we are in the same boat and we are going to be going forward together. So we're going to start by start by using the sample data set on. Can everybody see my screen? Am I audible?
Yes, we can see your screen.
Okay, so we're going to try by importing the sample data set on available on Power BI by importing it. So we're going to try and you choose the load sample data option. We're going to bring it in. And the second data set we are going to be using, it's a sample superstore data set, encompasses typical sales by a superstore entity based in the United States. It's fictitious, so it doesn't contain any actual data set from a specified company, but it's just generated. It encompasses all their total sales and their total transactions over time across their different branches, across different cities and states in the United States. So we're going to be bringing in these financials that's available on Power BI. So we're going to try and see what Faith was talking about when she was talking about typical denormalized, non-normalized, and normalized data set. This is how your Excel sheet appears for those of us in the using Excel or bringing in typical CSV files. This is how it typically occurs. It has its pros and its cons, as you can see. Every single information pertaining the financials in this data set are all on one particular table. You can see everything on the segment, the country, the product, the discount band, the unit sold. Everything is on one sheet. So we're going to go and try and bring the data set we're trying to use. So it's in an Excel workbook format. We go to get data and we bring it in. This is it, the Superstore model data. Well, this is what we'll be using. It's going to be available on Google Drive later at the end of this session. So for those that want to put their thumbs through it, they will be able to access it. And this model is going to be typically ideal for beginners and intermediate level Power BI and data modeling enthusiasts, and hopefully we do hope for those of us that are advanced, we try to get something out of this session. So for this session, we're trying to ensure that all of us try to pick something out of it, no matter if you're a beginner, intermediate, or in advanced level. So we're going to bring in the data by clicking on it and opening it up. So it typically helps us to bring it in. It's typically going to bring it in an import mode. So part of the data is going to be cached on Power BI. We're not going to touch on import, direct query, and dual mode in Power BI. Hopefully, some other time we might be able to touch on that. So here is going to open a window in which is going to allow us to bring in the sheets, because on the Excel file we have different sheets in this Excel workbook. So on this you can see something like these financials that we open. You can see a table on customers, a table on location, a table on orders, a table on product, and a table on sales rep. So we go and we click on OK, and we bring everything into Power Query. Power Query is the typical wrangling scrubbing, cleaning, cleansing tool for Power BI. It's a must know for Power BI users. It allows you to transform and make your data in any form that makes it easier for you to analyze and for you to visualize and for you to get insight out of your data set. Power BI is one tool you should know. For this, we're going to look at the data, and we can see that typically what we get on these financials is broken down in this table. So those are the perks and the cons of having your data in this form as opposed to having everything on one sheet. So this is what I would like. So let's imagine on this product, the manufacturers of this product have changed the name from Carretera to, let's say, Carretera X. So it means that we are going for every occurrence of Carretera on this table, we are going to need to change it. It's easier if your table is maybe 1,000 rows long. But what if your data is up to millions, tens of millions, hundreds of millions rows long? It means they're going to change everything. And in the end, for you to make such changes is going to affect performance. But when you break your items, when you break your tables down into multiple tables, it allows you to just go over to, let's say, products and just move and say, okay, you want to change Xerox 1967 to Xerox 1960. So instead of you having to change it all over, you just go to just one row, because it is all your products are all unique. Every product here occurs just once. So you can go here and just change it here. Since it's indexed already based on product ID, it allows you to change on every. It's allows you to reference it without having to make multiple changes. So it helps you to reduce data redundancy in which you're going to have to make, and it allows you to optimize performance of your data model by breaking down your data set in multiple tables that serves a particular function, like how Faith espoused a few minutes ago. How she explained to us a few minutes ago. So for this, we are going to you mentioned something about the concept of simple data. It says that for a data, it has to be concise, it has to be tidy, it has to be consistent. So we have to look through our tables, because the first thing about analyzing data, modeling data, is that for every tool you use in whatever field in IT, it runs on the principle of garbage in, garbage out. If your data is poor, data modeling is going to be poor, and you're analyzing data is going to be poor, and your insight generated is also going to be poor. So you have to ensure that any data that is coming into your tool for you to analyze is at the best shape. It has to be tidy, it has to be clean, it has to be consistent. So we have to go through our tables to ensure that everything is just how we expect it to be. As you can see that our column's name is column 1, column 2, column 3, and Faith said that we should ensure that it has descriptive name. So you can see that on row 1, you can see the descriptive names that is there. So we have to go to our Power BI on the home section, the home ribbon, and we go to the transform part, and we go to use first rows and headers, and we click on it. We don't use the drop down, we just click on it, and it automatically moves it up. As you can see that every single changes we made on Power BI is being documented on the apply steps column. So we go to the next table, and we check, okay, this is perfect. We go to orders, also perfect. We go to products, we will need to do the same thing. We go there and repeat the same step, and it brings it up. We go to the sales rep, and we can see that it has the same issue, and we move it to the headers. So for this, for us to connect our tables, we need to check and confirm that every primary key on the table it has a foreign key on the orders, which the others serve as the fact table. The other contains information on transaction, our day-to-day transaction. Why the dimension contains entity that describe, because you cannot talk about transaction in isolation. You talk about transaction based on who is making the purchase, what are they buying, where are they buying it. So those are the business questions you ask when you're talking about transaction. You can't talk about transaction in isolation. It has to have an explanation to that transaction. So those are the kind of explanation your dimension table brings to your fact tables. So we have to ensure that for every primary key we have on our dimensions, it has a matching foreign key on our fact table. So we can go through here and check. We have our order ID, we have our customer ID, we have our location ID, we have our product ID. But we see here we have our sales rep. We can use our sales rep to connect on our sales rep table. It will work. But you have to understand that in Power BI handles numerical data better than text data due to what it calls value indexing as opposed to hash indexing, then converts it back to value indexing. We're not going to go through that, but we just want to know that it makes it easier for Power BI to handle numerical values better than text values. So for here we might leave it here and connect it, but for this demo we are going to create what you call a surrogate key. Surrogate key is some sort of a primary key that has no bearing to any of the data sets, any of the data in the table being where it is being used. So for us to create a surrogate key, we typically have to just go to add column, and we go to the index column on general and click the drop down. I typically start mine from 1, which automatically creates an index, a sort of an index for each role on that table. So we can go here and we can just rename it to sales rep ID. And since we have sales rep ID, we need to bring it into our orders table for it to bring it so it can match every item on our orders table where a sales rep is available. So we go here and we go to our home and we go to combine. Then we click on combine and merge queries. It is here. We click on merge queries, and it helps us. It brings out a selection where we can be able to select which table we are trying to merge with our orders table, which is our sales rep, and we have to specify which columns occur on both tables. So we click on sales rep and we click on sales rep. As you can see, selection matches on 9,994 of 9,994 rows from the first table, showing that they are perfect matches. So we click on OK, and the table is brought in. So we try to open it by clicking this, and we first on select all. The select use original columns are prefix. Then we'll bring the column that we want, which is sales rep ID, and it's brought into the table we want. So for this, we've gotten everything we need to connect. And one of the best practices in Power BI is that every single table that you do not want on your Power BI report, you should always right click and disable enable load. It ensures that it is not brought into your Power BI and it just stays in your Power Query. That is something that you should always practice. You should ensure that any table you do not need for your analysis whatsoever, ensure you're not bringing it to your Power BI so it does not add to the size of your data model. So we click on close and apply. It will bring to apply the changes that we've selected, and we can see that all our tables should be coming up very, very soon. So we allow it to load, and it brings in everything we need. Hopefully it won't take so much time. Why it comes in, we're going to go over what we are going to be touching. We're going to go over the data sets. We're going to go over importing it. We're going to go over transforming it. We're going to create surrogate keys, and we're going to touch in and try to explain why we use the star schema and why I do prefer Roccoli's way of aligning the star schema. So we can see that everything has been brought in. Everything has been brought in. So we go to our data model, which is the model view, and we can be able to see all our data has been brought in and the model has been created for us. So we try to see everything. Power BI is intelligent enough to recognize connections in our columns and help us to create relationships. But one of the best practices is for us to always go and confirm, to always cross-check. So we go to manage relationship and we click on it. So it shows us all the relationship. And we can see that even though Power BI tried in some of the relationships, such as the orders to customer ID, location ID on orders to location ID on locations, product ID on orders to product ID on products, on sales rep, it uses the sales rep, and we want it to use this sales rep ID. So for this, we click on this and we click on edit. So we do not want sales rep ID, we want we don't want sales rep, we want sales rep ID, which is the numerical column. So we click on both and we click on OK, and you see it has been changed. So we click on close, and you can see that everything has been brought in just the way we want it. If we look at, we can see that everything is on a one-to-many relationship, just the way Faith said it. So we are going to try and design the Colis layout and see why I do like it. So now on Power BI, naturally on Power BI, the filter context allows you to be able to filter from your dimensions to your fact table. That doesn't mean you cannot filter from your fact table to your dimensions, but it's not the natural way in which Power BI filters. It filters on the direction of the relationship, which is from the one to the many. You can filter the other way around choosing both directions, or using advanced DAX queries, DAX functions to be able to specify that. But we won't be touching that. But the natural way Power BI automatically does it is to filter from your one to your many. By aligning your dimensions table at the top and your fact table down, it typically allows beginners and those trying to get into data modeling to understand the filter context, understand the direction in which their items are being filtered. So I do like Rob Colley's method of aligning the star schema. So for this, before we can be able to do some analysis on typical transaction data, we might need to on some of the analysis, we might need to do some time intelligence functions such as year over year, year to date, month over month. And for that, we need a dedicated date table. You might ask, on this other table, we have what you call the other dates, we have the ship date. Why don't we use that? The issue on using the date column on your Power BI, on your default date, on your default tables is that let's imagine that on between the days of Mondays to Sundays, our store only opens Mondays to Fridays. For 2 days, we do not open due to we're trying to take the weekend off. On those 2 days in which the stores are closed, we are not going to have any transaction done on those days. And on your records, you won't have any records for those days. For Power BI, for you to make time intelligence functions, you have to have consistent days between all the periods in time you are trying to make your analysis. So if you are doing analysis between the year 2015 to 2020, you have to have consistent days on your records for Power BI time intelligence functions to be optimal. So that is why you need to create a date table containing all the dates within those time periods you are trying to make your analysis. So for this, we are going to try and create our date table. You can create your date table on Power Query. You can copy and paste it. You can import a data set containing your date table. But for this demo, we are going to create our date table using DAX. So how do you create it? You just specify your table tools and you go to new table. New table is going to open a writing area where you can write your DAX formulas and you're going to create your table. For us to speed up, I have a Word document where I've already pre-written everything on our date table. It's going to be available for those that want to write it. I could write it from scratch, but for us to specify it, for us to work with time and try not to go behind on our time, we're just going to copy it and are going to paste it in our writing environment. So you can see there are no errors, so we're going to try and click. For this date table, we're trying to create our calendar year, and we're going to try to create our month number, which is what you're going to use to sort the month name we're creating next using the format function. We're going to create our date number, which you're going to use to sort it, because once you create your month, January to December, you're going to use the numbers 1 to 12 to sort it. So it's going to be in the right order. January is going to be 1, February will be 2. And you can always sort it based on if you want to create your fiscal year, in case your fiscal year starts in April or your fiscal year starts in June, you can use the month number and specify it however you want to create it. So we click on commit and it should create our date table the way we want it. So we can see that it has been created. One of the best practices you have to do is by you should always mark your date table. You click on date, it's still on date tools. You see mark as date table, you click on mark as date table. It's going to ask you for your date column, which is this. You're going to specify that, and once it shows validated successful, you are good to go. It's going to mark your date table as, it's going to mark what you just created as a date table. So you click on that and you go to your data, your model view, and you're going to try to connect the newly created date table with your orders table. So now it gives us a unique perspective here. If you go to your table view and you open your orders, you can see that we have our order date and our ship date. So now let's imagine we need to calculate we have a business question in which we want to calculate the amount of orders we made and the amount of items. So there are particular ways, and you remember what Faith said. He said you can only have one active relationship in Power BI. You can have an active and you can have an inactive, but at a particular time there should be only one active relationship on Power BI. So now there are multiple ways you can be able to do that. You can just create role-playing dimension tables, or you can use DAX to be able to maximize the usage of inactive and active relationship in this method. So, but in this demo, we are going to try to use DAX to maximize the active and active relationship. So we're going to create two relationships on this from our date table to our orders table, and we're going to use active and inactive relationship to try and see if we can be able to. We're going to try to see if we can be able to make the same calculations using the two date tables and see if we're going to get two different results. So we're going to go to our model view and we're going to drag our date table. We're going to drag our date table, or we can use the drag and drop on our order dates. And we can drag and drop the ship on our other dates. So you can see there are two relationships, one active, one inactive. So the active one is on order date, the inactive one is on ship dates. So for that, we are going to try and see, since everything is the way we want it to be, let's test it on report view. So we're going to create some metrics, like how Faith said, we're going to create some measures. And I typically like all my measures to be in a singular table. So I just click on enter table, which is on the home ribbon, and I change it and I click on underscore metrics. I typically like to call it metrics. But I use the underscore to ensure it's alphabetically it moves to the top. So on my metrics table, I click on and I create a new measure. And for this, I'm going to create a measure called total revenue. And you can see on our orders table, if we click on this, we can just create total revenue. Total revenue, calculating total revenue is by the unit price multiplied by the quantity sold. So we can just go to the Word document and just copy it. I already prepared already, so not to waste more time. Using the iteration formula, the SUMX formula, we're calling the tables, we're multiplying it by the sales and the quantity. So we click on it. And we bring it in and we can see that the total revenue is a card visual. Total revenue for the superstore is 11.49 million. So let's now create a year-to-date metric using the order date first, then using the ship date. So we try to calculate the revenue year-to-date on the days in which we have orders and on the days in which we shipped our items. So we still have it on the same Word document. We can just copy and paste it for that ease. This is using the order data, and you can see that we use the use relationship function to specify the connection we want to activate as of that time. So we click on this and it gives us a particular value. And we can go back to our Word document and do the same for our ship date. So if we bring both items bring the other into a car visual, you see that we have 3.5958 million. How we bring the year-to-date ship date into a car visual, we see that we have 3.56 million on the days we ship. So without having to create an extra date table or try to duplicate the date table and run a calculation, by still having the same number of tables we start from beginning, we can use inactive relationship and accompanying with DAX to create it. So those are the perks of using DAX using DAX in data modeling. It allows us to not add more tables to already bloated data model, but we can use DAX to specify relationship as a when due. So instead of us, because it's easier for us to just create a new data table here, date table, and connect it, but it is not ideal in the end, because if you have a date table, if you have a data model with, let's say, 30 tables, 50 tables, and you need to create date tables for each of them. If you have different order dates of up to 5 to 6 to 7 to 8 to 9, you need to create them. So for this demo, we're going to stop here, and I hope that the demo has been insightful and has been as much as enjoyable as it has been for me. And I hope, and I will be taking any questions that you guys, that anybody have, we're going to be taking it. We thank you all for staying with us. Thank you.